but there I have finished the second chapter as well. Totally 6 chapters finished in that batch. Your batch only 5 has been done.
Ma'am, that is also KVs.
No, they are not KV.
Oh.
All different speeds. Chemistry, second chapter is matter around us pure. So here matter is divided chemically into 2 parts. What are those?
Pure substance and
Pure
mixture.
Pure substances and
Pure
mixtures.
substances. Pure substances and mixtures. Pure substances, or also we call only substances. This. Pure substances or simply substances. Further, pure substances are, what are pure substances means?
Elements and compounds of the same same type of
Elements and compounds.
Ma'am, elements and compounds.
Definition.
Ma'am, pure substances definition.
Yeah.
The substances which have same type of atom or molecule are called as pure substance.
Ma'am, which are same throughout.
Ma'am, made up of similar kind of atoms and molecules.
Made up of similar kind of atoms and molecules. Made up of similar kind of atoms or molecules are called as pure substances. So pure substances, depending on it is an atom or it is a molecule, then it is called this one divided further into elements and compounds. Here it is made up of similar types or kinds of atoms. So single atoms will be seen everywhere, and compounds
Made up of similar kind of
Made up of similar kind of molecules.
Molecules.
similar kind of molecules, and these molecules are made from
kinds of atoms.
Two or more
different atoms
made
combined.
of different types of atoms. If this molecule is of similar atom, then it is still a element only, right? So why I have told here molecules, but molecules is also of similar kind or maybe of different kind. So therefore, if there is a single molecule is made up of different types of atoms, then it is compound. But if it is made up of similar type of atoms, then it is called as elements. Clear?
Yes, ma'am.
Then what are mixtures? Mixtures are
They're made up of 2 or more substances that are mixed physically and in any proportion.
yes, made by mixing 2 or more chemically non-reacting substances.
Ma'am, it's mixing physically.
Yes, non-reacting substances in any proportion. The proportion is not fixed. Then mixtures, depending on uniformity in mixtures, they are divided into homogeneous and heterogeneous. So homogeneous means uniform composition, and particles are not visible. In case of heterogeneous, the composition is non-uniform. non-uniform composition, and particles are visible. Constituent particles actually. Particles are visible. Then those called as heterogeneous mixtures. Okay, it's clear?
Yes, ma'am.
Yes, ma'am.
Examples of elements?
Ma'am, H.
H,
Hydrogen, nitrogen,
Ma'am, magnesium.
hydrogen, nitrogen, potassium, magnesium,
sodium,
Ma'am,
sodium,
gold, silver.
gold,
Silver.
Ma'am,
silver.
zinc,
Copper.
Which one?
Ma'am, tin.
copper,
lead,
Copper,
Potassium.
right?
Ma'am, tin.
Potassium, tin, lead,
zinc,
Magnesium.
zinc, right?
boron,
Gallium.
Gallium,
Ma'am, silicon.
Chromium.
silicon, chromium,
Magnesium.
magnesium.
mercury,
Hmm.
Chromium.
Yes, done. Mercury, chromium,
beryllium,
hmm.
helium,
Beryllium,
Ma'am,
helium,
iron.
barium, iron.
Ma'am, but I have heard that iron.
bromine,
Ma'am, I have heard that iron means the iron which we use is not. It is a mixture.
Which iron?
Ma'am, like the in iron smith.
Yes, whatever the iron we use, that is a mixture. It is not a pure iron.
Yeah,
Pure
real
iron is
pure
very
iron is
soft.
soft.
Very
Yeah.
soft. So it has to be mixed with carbon or any other substances. Carbon, nickel, chromium has to be added so that it is the alloyed. It is actually alloy of iron we are using with impurities. So pure iron is very soft.
Ma'am, but we don't call it alloy.
It is impurity along with impurities. The complete purification has not been done.
Yes, ma'am.
Okay,
Ma'am, limestone.
it's compound,
Oh,
calcium carbonate. So elements are further divided into
metals, non-metals,
four types,
alloys, and inert gases.
noble gases,
Gases, noble gases.
elements are divided into metals, non-metals, metalloids,
Inert gas.
Noble gases.
inert
noble
or
gases,
noble gases. What are metalloids?
Ma'am,
Ma'am,
which
the
show specific properties of
um,
metals and non-metals.
intermediate properties.
Yes, intermediate properties. The elements which have properties intermediate to metals and non-metals. Example,
Ma'am, silicon.
silicon,
silicon,
Germanium.
germanium,
germanium,
Boron.
boron,
Ma'am,
boron.
radium.
No, radium is not.
Arsenic.
Arsenic, polonium, bismuth is also a metalloid. Okay, inert gases.
The gases which are not
Yeah,
included
gases
in any chemical
don't react
reaction.
with anything.
Chemical reaction that are found in gaseous state are known as intermediate or noble gases.
Inert, chemically inert, do not take part in any chemical properties.
Ma'am, really means we can't heat and oxidize them.
We can heat them but not oxidize, they do not. Some
Okay.
of the elements, krypton, radon, so when heated very strongly under very extreme conditions, that is after applying pressure, they can combine. Few chemical reactions can be seen, but under very extreme conditions.
Okay, ma'am.
Neon, helium,
argon,
argon, krypton,
Xenon.
neon,
Radon.
krypton,
Krypton,
xenon, and radon. Six.
Ma'am, total how many inert gases are
Six.
present?
Six. Only 6. Okay, now metals and non-metal difference. Physical properties according to physical property wise.
Ma'am, luster.
Malleable.
Luster.
Solid.
Lustrous.
These are hard solid and these are
soft
Ma'am,
mostly
and gaseous.
soft.
Very few are in solid.
few solids but in amorphous form. Amorphous, that means powdered form. They are not forming any solid shape, they are powdered form.
Okay.
And liquid non-metal, or only one liquid non-metal, that is bromine. Bromine water we call it as. Hard solid, exception is only
Sodium.
liquid metal
Ma'am, mercury.
is mercury. And sodium, potassium, lithium,
Soft metal.
soft, can be cut easily with knife. Can be cut easily with knife.
Ma'am?
Yes?
Ma'am, so the pure iron also can be cut with knife.
No, it is soft only. We can press it, but cannot be cut.
Okay.
It's only we can press it. So that is, it can be D-shaped, but cannot be cut. Then second one,
Means it is
Ma'am, luster.
Malleable, ma'am. Malleable.
lustrous, non-lustrous, malleable, ductile, non-malleable, non-ductile, sonorous, non-sonorous,
not able to hear you.
Ma'am.
even I know.
Same here.
Same here, ma'am.
Can you hear me? Can you hear
Yes, ma'am.
Yes, ma'am.
3, 4. Okay. High melting and boiling points. These are
Low melting and
low
melting.
melting and boiling points.
Ma'am, high
Ma'am,
tensile
malleable.
strength.
Ma'am, good conductors.
Good conductor of heat and
Ma'am,
electricity.
high tensile.
Good conductors of heat and electricity. And this have
Poor conductor
poor
of heat.
conductors, poor or bad conductors.
Yes.
Metals have high density.
Generally,
High density
ma'am,
High
for
density.
metals.
Ma'am, there is an exception in the non-metals, right? Which is
What?
the good conductor of
yes, ma'am.
This
Graphite is good conductor of
electricity
electricity.
is,
graphite.
for electricity is the graphite and for heat is diamond.
Okay, ma'am.
Ma'am, for strength is
Ma'am,
diamond.
so we can write
And even here, there is an exception. Cesium, gallium. Cesium and gallium have a very low melting point and boiling points. Melting point is actually the room temperature. So they immediately, when you keep it in on palm, keep those metals on palm, they melt. So our body heat is enough for them to melt. Clear?
Yes, ma'am.
Okay, so write down all these points. And high tensile strength also. Metals have high tensile strength, non-metals do not have.
Ma'am, we have to write this. We already wrote it.
Yes, write it down again. So from this part.
Ma'am, what is the meaning of electropositive?
Electropositivity, that means the losing of electrons, the property of losing electrons.
Ma'am, in the Sapiens educational notes, it's written.
Yeah, metals are electropositive and non-metals are electronegative, right?
I didn't understand, ma'am, the meaning properly.
Yeah, I will explain. First write down this physical properties, then I will explain you the chemical properties.
Okay, ma'am.
Chemical property wise, how are they different from each other?
Ma'am, can you scroll a bit down?
Ma'am, can you scroll a bit up?
Done, ma'am.
Have you done?
Yes,
Done,
ma'am.
ma'am.
Ma'am, last 2 minutes.
Okay. Others, have you finished?
Yes, ma'am.
It's done, ma'am.
Done.
Yes. I'm done, ma'am, already.
Now next is difference between compounds and mixtures. Main difference, it is a 3-mark question. Yes, first point.
Ma'am, compounds are two or more elements that combine chemically in fixed proportion by mass.
Yes, 2 or more elements combine chemically in fixed proportion by mass. And in case of mixtures, 2
Ma'am,
or
two substances mixed together physically in any proportion.
mix together physically in any proportion. Second point.
Ma'am, energy is involved in the formation of compounds,
Yes.
and they have a fixed melting point and boiling point.
Yeah. So here energy is involved in formation or separation of compounds, and here energy is not involved. Then third,
They have a melting point and boiling point.
fixed melting point and boiling point. Here
They don't have fixed melting point and boiling.
melting point and boiling points are not fixed. Then further,
They
Ma'am,
don't
the
retain the properties after they form compounds.
constituent particles do not retain their original properties. Constituent particles do not retain their properties. Here, constituent particles retain. Their properties. Further, is there anything else?
In ma'am, the compound constituents cannot be separated by physical process.
chemical processes.
Constituent particles are separated only by
Chemical process.
chemical process. Constituent particles are separated by chemical process only, and here
By physical
separated
process.
by physical properties. Constituent particles separated by physical properties.
Ma'am, physical processes.
Physical processes, sorry. Anything else?
No, ma'am. Examples.
One compound is a homogeneous substance, and it shows a homogeneous or heterogeneous substances.
Okay. Composition is uniform or homogeneous substance. Here it is homogeneous or heterogeneous. Or heterogeneous. Okay, so these are the differences between compounds and mixtures, and which is asked for 3 marks. Clear?
Yes, ma'am.
You have written?
Yes, ma'am.
Now.
Yes, ma'am.
Whoever not written, complete. 2 minutes time.
Done, ma'am.
Completed?
Yes, ma'am.
Yes.
This is all about the elements and compounds. Next, further in this chapter, you have learned the mixtures. So mixtures are two or more substances when combined in any proportion. So mixtures are further divided into
Homogeneous and heterogeneous.
homogeneous and heterogeneous. Homogeneous means here differences between homogeneous and heterogeneous.
Size of particles less than 1 nm in homogeneous,
Okay, size of
and
particle.
size of particles more than 1 nm, between 1 to 100 nm, or more than 100 nm.
That is more than one.
Yes, ma'am.
Less than 1 nanometer. And here size of particles more than 1 nanometer.
Ma'am, the substances are uniformly distributed.
Yes, constituent particles are not visible by naked eyes. And the second one, are you able to hear me?
Yes, ma'am.
Constituent particles are either seen by naked eyes or under microscope, under simple microscope.
Ma'am, this particles means just solute or a
Solid
particle.
particles.
Yeah.
Solid particles. Third one, what you told, Sushila?
Some substances are uniformly distributed.
Uniformly distributed particles. And here,
Ma'am, unevenly distributed.
non-uniformly or unevenly distributions.
Ma'am, for homogeneous, boundaries of separation are visible, not visible.
Boundary of separation not visible. That is only one phase is seen. And here boundary of separation is visible. That is two or more phases. Examples?
Ma'am, one more point. The homogeneous mixtures are called solutions.
Are called solutions.
And heterogeneous are called suspensions or colloids.
Colloids or suspensions.
Ma'am, example of homogeneous mixture can be alloys,
Alloy. Okay.
water and salt.
Salt.
Sugar solution.
Sugar solution or sugar syrup. Okay. And
Lemonade.
lemonade, air.
Copper sulfate solution.
What?
Copper sulfate solution.
Copper sulfate solution.
Ma'am, tea is heterogeneous, right?
What tea is homogeneous? Which tea? Dry one or liquid one?
Ma'am, liquid one without milk.
Without milk, it is this one. Filtered tea is homogeneous.
Yeah, filtered tea.
Yeah, filtered tea is homogeneous.
Ma'am,
Yes.
ma'am, is there a difference left that homogeneous mixtures do not show Tyndall effect?
Yes, you can write. Yes, right. Homogeneous mixtures do not show Tyndall effect. Heterogeneous shows Tyndall effect. You are getting much more noise from my side.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
How work is going on? That's the reason. 1 second. I will close the door. Now is it better?
Yes, ma'am.
Yeah. The house work is going on. The welding is going on. Okay, cool. Yes, right. That is about the Tyndall effect. You can show. Alloy again. What is tincture of iodine?
Ma'am,
What is tincture of iodine? Tincture of iodine.
From iodine mixed in water.
Alcohol and iodine.
Ma'am, is it a
Iodine.
mixture of
It is
iron?
used. It is used for medical purposes.
Tincture of iodine is a mixture of, right, Daphne? It's iodine and alcohol. Iodine and alcohol both have the property of disinfectant. So they removes any germs in the wounds. So therefore it is used as ointment,
Disinfectant.
disinfectant, ointment. In the ointments, the tincture is used. Tincture of iodine is used. So tincture of iodine is also a solution. That is iodine and alcohol mixture. Gunpowder is also solution. Okay, any other examples?
Ma'am, what gunpowder?
Yes, gunpowder. Not eaten, not the which you use is it is used to eat. The gunpowder that is used in bullets.
Yeah, in crackers.
Yeah, crackers as well as bullets. That gunpowder is a solution. Now this one, heterogeneous mixtures.
ma'am, pizza,
Okay,
Buttermilk.
oil and water,
buttermilk.
oil and water,
Ma'am, lemonade.
Lemonade is not oil and water, right?
Any
Lemonade,
flavored rice. Flavored rice.
Sorry.
oil
A-
plus water.
Any type of flavored rice.
Okay, flavored rice. All the food actually it is all types of cooked food is a mixture heterogeneous.
Ma'am,
Salt.
chalk in water solution.
Chalk plus water. Yes, again.
Ma'am, soil.
muddy water,
Oil, muddy water.
Ma'am, is blood heterogeneous?
Yeah, blood is a colloid, so it is heterogeneous.
Ma'am, plastic.
Ma'am, milk.
What about cement?
Ma'am, plastic.
Yes. Plastic is a compound.
Okay.
Ma'am, honey?
What do you call it? One more. Ganesh, what you told?
Ma'am, milk.
Milk, right.
Ma'am, honey?
Honey,
Shaving cream.
Ma'am,
Ma'am, vinegar.
shaving cream.
ma'am,
Yes.
ma'am, honey is heterogeneous.
Yeah, honey, there are many different nectar is present in it.
Ma'am, but we are not able to see different components of that.
It is sometimes. It is filtered one, no.
Ma'am, ink. It is homogeneous, no? Ink.
There is solution.
Yeah, it's homogeneous.
Yeah.
Ma'am, vinegar.
Vinegar is mixture. Homogeneous.
Okay.
Ma'am, sand water? Sand plus water?
Sand plus water, right?
Ma'am, paper.
So no, honey is paper is a compound. We can call as heterogeneous, right? Honey will
Soap solution.
Honey is wrong. Soap solution, okay. Colloid it is. Soap solution is colloid. Honey is wrong here. It is homogeneous.
Okay.
And smog.
Smog will come, yes. Colloid.
Ma'am, rainwater?
It's mixture. Solution, please.
Paint.
Paint is colloid.
Ma'am, glass is a solution.
Glass is a solution, homogeneous. Okay, fine. So these are the
Soda
examples.
water.
Soda water, homogeneous solution.
Okay.
Okay. Now the next is homogeneous and heterogeneous, right? This is 2-mark question with example they can ask you. So that means the example is given. You have to find out whether it is a homogeneous or heterogeneous mixture. So that was the question. After further division is solution, suspension, and colloid. So difference between solution, suspension, and colloids is there. Solution, colloid, suspension. First point, particle size.
Ma'am, it is a
Less than
homogeneous.
1 nanometer.
I'm not writing now. Okay, yeah, solution is homogeneous mixture, right? Homogeneous. Colloids is
It looks homogeneous, but it is
heterogeneous.
Heterogeneous.
Looks homogeneous, but it is heterogeneous mixture. Suspension is also heterogeneous mixture. Is it the particle?
The size of particle is less than 1 nanometer.
Size is less than 1 nanometer. Colloids
In
is
colloid, it is between
It
1
is
nanometer to
between
100
1
nanometer.
one to
nanometer
100.
100 nanometer.
Yes.
In suspension, it is more than 100 nanometer.
Yes, right. Solution is the size of the solution is less than
More than
colloids between 1 to 100 nanometer, and the suspensions are more than 100 nanometers. Then Tyndall effect.
solution don't show Tyndall effect.
Solution do not show Tyndall effect. Colloids and
Tyndall effect.
suspension shows Tyndall effect. Filterability.
Solution in solution, solute particles pass through filter paper.
Yeah. Solutions easily pass through filter paper as well as semi-permeable membrane. Colloids pass through filter paper but do not pass through semi-permeable membrane. And in suspensions, they can not pass through filter paper as well as semi-permeable membrane.
Ma'am, are you writing?
No, I'm not writing.
Yeah. I thought there's net problem.
No. I'm not writing.
Ma'am, solution do not show Tyndall effect.
Yes, that's sure. Just now told.
Oh,
Ma'am, solution is stable and colloid is also stable, but suspensions are unstable.
Yes, right. Solutions are stable. That means they do not settle. The particles, constituent particles, do not settle down when left undisturbed. Colloids also are stable. The particles, solid particles or constituent particles, do not settle down when left undisturbed. But the suspensions is unstable. They settle down. The particles, solid particles, settle down when kept left undisturbed.
Solutions are transparent
Yes, solutions are transparent.
Translucent and
Colloids are
opaque.
translucent.
and suspensions are
Turbid, opaque.
opaque.
Okay, so write down these points by yourself. 5 to 6 points are there, so write it down.
Ma'am, you told ink is a homogeneous solution,
Homogeneous.
but it's not transparent.
It is
Ma'am,
when
it is some
diluted form. When you take it, it's you can easily see through.
yeah, but ink blue, black.
More amount of solute is there, then it is not.
Okay.
Ma'am,
Yes.
are you writing on the board?
No, I'm not writing. You have to write down.
Okay, ma'am.
Ma'am, colloids also have one phase. Only suspension has two or more phase.
One phase is not there actually, because when seen under microscope, you can see two phases.
For colloids.
In colloids, yeah.
Okay.
Completed?
Yes, ma'am.
Ma'am, I got 8 points.
Good. Okay, fine. Then now I will start now further. Now read the further part. Further, what is left out? That is different types of solutions, solubility, concentration of solutions. The part under the solutions. The different types of a solution: saturated, unsaturated, supersaturated. Then solubility. Then it is a concentration of solutions. So that part you have to learn, and then the separation of mixtures. So next class we will continue that. Fine. Now start maths.
Ma'am?
Yes.
Ma'am, I'm not able to hear you correctly. Can I rejoin?
Okay, fine.
Okay.
We will start maths now.